Good morning, students. How are you? Hope you are good and doing well. Today we are going to discuss about factorize a cubic polynomial. Cubic polynomial means degree of x is 3. Here highest degree of x is 3. So let given function is a p of x. So p of x is equals to x cube minus 23x square plus 142x minus 120. This is type 1 problem. Generally, these type of problems we have to solve by using three types of methods. The first one is corner division method, and second one long division method, and third one factorization method. This is cubic polynomial. Means the highest degree of x is 3. Means this type of polynomials having 3 factors. So by using corner division method, we have to find at least one of the factor of given polynomial. So by using trial and error method, first take a 0 instead of x, that is x cube means 0, 23x square 0, and 142 into x is also 0. So finally constant is minus 120, so the result is also minus 120. So substitute 1 instead of x instead of polynomial p of x. So that is equals to 1 cube minus 23 into 1 square plus 142 into 1 minus 120. So final result is minus 143 plus 143, that is equals to 0. So p of 1 is a factor, means x minus 1 is the factor of p of x. This is the procedure of corner division method. So first we have to take coefficients of given polynomial. Here x cube coefficient is 1 and x square coefficient is minus 23, x coefficient is 142 and constant term is minus 120. So in a corner division method, we have to take 0 underneath the first coefficient. So this substitution of 0 is common for each and every problem. 1 minus 0 is equals to 1. 1 ones are 1. Minus 23 plus 1 is equal to minus 22. Minus 22 ones are minus 22. 142 minus 22 is equals to 120. 120 ones are 120 plus 120 minus 120 cancels, so result is 0. So write this coefficient properly, and here 120 is the coefficient of x power 0 and minus 22 is the coefficient of x power 1, and here 1 is the coefficient of x square. So this is a quadratic equation. So factorize equation 1. We know that middle term splitting method. So minus 22 is the combination of 12 and 10. Summation of middle term and product of extremes. Condition is satisfied. Here in these two terms, x is common, remaining terms are x minus 12. Here minus 10 is common, remaining terms are x minus 12. So entire x minus 12 is common and remaining terms are here x and here minus 10. So finally the factors are, first by using trial error method we get one of the factor, that is x minus 1, and remaining factors are by factorizing the quadratic polynomial, that is x minus 12 and x minus 10. Next method is long division method. By using trial and error method we already get x minus 1. So by using trial and error method, x minus 1 is a factor of p of x. So we have to take g of x is equals to x minus 1. So divide these p of x by g of x. So that is equals to, we already know this procedure. X minus 1 is the g of x and this is the dividend, that is equals to p of x. So this is our quotient, that is equals to q of x. So this one is the remainder r of x. So generally we know this method. First we have to divide polynomials first term by divisors first term, that is equals to x cube by x. Result is x square. Multiply this x square with x minus 1. Result is x cube minus x square. So minus 23x square minus x square. Subtraction result is x cube cancel, result is minus 22x square. So bring down the minus 142x. Divide this results first term by divisors first term, that is equals to minus 22x square by x. So result is minus 22x. So minus 22x into x minus 1, that is equals to minus 22x square plus 22x. So our deduction result is minus 22x square plus 22x square cancel. So 142 minus 22 is equals to 120. Bring down the last coefficient, that is equals to minus 20. Divide this first term by divisors first term, that is equals to 120x by x. So result is plus 120. Multiply this 120 with x minus 1. Result is 120x minus 120. So here both terms are cancelled, result is 0. We already know the division algorithm, that is p of x is equals to, so g of x into q of x plus r of x. Here the results are x minus 1, so x square minus 22x plus 120 plus 0. So here q of x is equals to x square minus 22x plus 120. Factorize this q of x by using middle term splitting method. We get remaining two factors of the given polynomial, that is p of x. Our quadratic equation is x square minus 22x plus 120 by using middle term splitting method. So factors of 120 is equals to 12 into 10, and addition result of 22 is minus 12 minus 10, that is equals to 22. So both conditions are satisfied. What are the both conditions? The summation of middle term and product of excrements. So here x is common, remaining terms are x, here minus 12, here minus 10 is common, remaining terms are x, and 10 12s are 120, 12 is remaining one. So that is equals to x minus 12 is the entire common term, here remaining terms are x, here minus 10. So the factors of cubic polynomial are x minus 1, x minus 12 and x minus 10. So this is final method, that is factorization method. So our given polynomial is a cubic polynomial. In this method we are splitting middle terms. These are the middle terms, that is minus 23x square and 142x. We have to write these 23 in terms of two term combination, that is minus x square minus 22x square. Result is minus 23x square plus 142x is also writing two term combination, that is 22x and plus 120x. This splitting depends upon first term and last term. This type of splitting depends upon first term and last term. By splitting we get three pairs of combination. Here x cube minus x square is a combination, minus 22x square plus 22x is a combination, and 120x and minus 120 is a combination. So three pairs of combinations. So here x square common, remaining x minus 1. Here is also minus 22x is common, remaining x minus 1. So here 120 is common, remaining terms are x minus 1. In this entire term x minus 1 is common, so remaining x square minus 22x and plus 120. So this is a quadratic polynomial. Factorize this polynomial, you can get x minus 10 and x minus 12 are the results of this quadratic polynomial. X minus 1, x minus 10 and x minus 12 are the factors of given polynomial. Next our problem, second one, y cube plus y square minus y minus 1. This is type 2 problem. So this type of problems we can get the factors directly by without splitting any middle terms. We have to take y square as a common term from these two terms, that is equals to y square is common, remaining terms are y plus 1. Here minus 1 is common, remaining terms are y plus 1. So entire y plus 1 is common. So remaining terms are here y square, here minus 1. So this is method 1 to solve this type of y square minus 1 equation. So y square minus 1 is in the form of y square minus 1 square. So it is of the form a square minus b square, that is equal to a plus b into a minus b. Here y square minus 1 square is equals to y plus 1 into y minus 1. So this is method 2. So y square minus 1 equating to 0. So that is equals to y square is equals to 1. Y is equal to square root of 1, that equals to plus or minus 1. So y is equals to 1, y is equals to minus 1. So we can get y minus 1 and y plus 1. So factors are y plus 1, y plus 1 and y minus 1. This is our third one from exercise 2.4, fifth question. If both x minus 2 and x minus 1 by 2 are the factors of px square plus 5x plus r, then show that p is equals to r. So here f of x is equals to px square plus 5x plus r, and g1 of x is equals to x minus 2. This is a factor, means f of 2 is equals to 0. So here is also factor, means f of 1 by 2 is equals to 0. So by the remainder theorem, x minus 2 is equals to 0, x is equals to 2. So substitute this x value instead of x in given polynomial. So that is f of 2 is equals to p into 2 square plus 5 into 2 plus r. So x minus 2 is a factor, means f of 2 is equals to 0. That is equals to 4p plus 10 plus r. This is equation 1. So by the remainder theorem, x minus 1 by 2 is equals to 0, x is equals to 1 by 2. Substitute this x value instead of x in polynomial. So f of 1 by 2 is equals to p into 1 by 2 whole square plus 5 into 1 by 2 plus r. So x minus 1 by 2 is a factor, means f of 1 by 2 is equals to 0. That is equals to p of 1 by 4 plus 5 by 2 plus r. Here 4 is the LCM. 0 is equals to, for 1s are 4, 1 into p is equals to p plus 2, 2s are 4, 2 into 5 is equals to 10 plus 4 into r is equals to 4r. So 0 is equals to, transpose this 4. So 0 into 4 is equals to 0. That is equals to p plus 10 plus 4r. This is equation 2. So this is our equation 1 and this one is equation 2. By the elimination method, multiply this second equation with 4. 4 into P 4P, 4 into 10, 40, 4 into 4, 16R is equals to 0 is equals to 0. So, by the elimination method means subtraction. 4P minus 4P is equals to 0. 10 minus 40 is equals to minus 30. Plus R minus 16R is equals to minus 15R is equals to 0. So, minus 15R is equals to minus 30 transposes to plus 30. R is equals to 30 by 15 is equals to minus 2. So, value of R is equals to minus 2. Here, substitute this R value in equation 2. So, that is equals to P plus 10 plus 4 into minus 2 is equals to 0. R is equals to minus 2, R is equals to minus 2. So, P plus 10, for 2s are 8 plus into minus, minus 8 is equals to 0. So, P plus 2 is equals to 0. Plus 2 transposes to minus 2. So, final result is P is equals to minus 2. So, R value is equals to minus 2, P is minus 2. So, here finally the result is P is equals to R. This is our sixth question from exercise 2.4. So, if x square minus 1 is a factor of ax power 4 plus bx cube plus cx square plus dx plus e, show that a plus c plus e is equals to b plus d is equals to 0. Here p of x is equals to ax power 4 plus bx cube plus cx square plus dx plus e. Here g1 of x is equals to, so this is of the form a square minus b square, that is equals to x square minus 1 square. 1 square is nothing but 1. So a square minus b square result is a plus b into a minus b. Similarly, x square minus 1 square result is x plus 1 into x minus 1. Here x minus 1 is equals to g1 of x and x plus 1 is equals to g2 of x. So x square minus 1 is a factor, means equating g1 of x and g2 of x, both are equals to 0. So substitute 1 instead of x. P of 1 is equals to a 1 power 4 plus b 1 power 3 plus c 1 square plus d into 1 plus e. So P of 1 is equals to 0 by the given data is a factor. X is equals to 1 is a factor, means P of 1 is equals to 0. So remaining terms are a plus b plus c plus d plus e. So here g2 of x is equals to x plus 1. Factor means let g2 of x equating to 0. So x plus 1 is equals to 0, x is equals to minus 1. So here P of minus 1 is equals to, substitute this minus 1 instead of x, that is equals to a into minus 1 power 4 plus b into minus 1 whole cube plus c into minus 1 whole square plus d into minus 1 plus e. So P of minus 1 is a factor, means that is equals to 0, is equals to a minus b plus c minus d plus e. Transpose these negative terms, that is equals to b plus d is equals to a plus c plus e. This is equation 2. Transpose b and d terms. So minus b is equals to a plus c plus e. This is equation 1. This is equation 1 and equation 2. Substitute equation 1 in 2. Substitute this value in equation 2. That is equals to b plus d is equals to a plus c plus e is equals to minus b minus d. Minus b minus d. So transpose these terms, b plus d plus b plus d is equals to 0. Here 2b plus 2d is equals to 0. Take 2 as common term, that is equals to 2 into b plus d is equals to 0. transpose 2, that is equals to b plus d is equals to 0. This is equation 3. From equation 2, a plus c plus e is equals to b plus d. This is equation 2. From equation 3, b plus d is equals to 0. This is equation 3. So here we can conclude that a plus c plus e is equals to b plus d is equals to 0. Hence proved. In exercise 2.4, Roman number 7, 8, 9 and 10 as your homework. If you have any doubts, please contact my number. Thank you.